Tom and Keenan are our guests from Georgia Tech, and they're going to talk with us for about 15-20 minutes on some of the gesture work that they've been doing. They presented on over the last number of years at Auto UI, and some of those of us who attend Auto UI have found it very interesting, and so we thought it would be useful to share it with the rest of you who don't regularly attend that venue. So, Tom?
Yes, sir.
Okay. Why don't you go ahead, and I will attempt to move through this as you talk.
All right. Thanks, Tim. Hi, everyone. My name is Tom, and this is Keenan. We are both PhD students in Bruce Walker's Sonification lab at Georgia Tech. Just a quick background on our lab before we get started. Our lab is a multidisciplinary lab, so Bruce is actually in both psychology and computing, which gives us a lot of really interesting abilities to do research where we combine students on teams like myself, which is a PhD in engineering psychology, very much a psych-heavy person, and I get to work with computing PhD students and master's students who can help me to create really great tools and interfaces such as the ones we're going to talk about today. So, Tim, if you can go to the next slide.
Maybe.
Potentially. All right. So, so gestures in the vehicle have been a topic of interest for a long time. People have shown a lot of demos of people driving down the road and making a gesture with their hand, and suddenly their favorite song starts playing. And they are a really, really interesting use case. They unlock a lot of new methods of interaction that people can use, and they promise a lot of flexibility. What is not necessarily always understood there is, and conveyed in those videos and those talks of use, is the possibilities that are not shown in those, and the hazards that are not shown there. So gestures are becoming more viable for use in the vehicle, and they are unlocking more and more potentials, but there's still some issues, and we're going to talk about that. But what we really want to focus on here is assuming that sensors are just working. There are other concerns that designers and human factors practitioners need to watch out for. And so we're going to talk about those as we go through today. So the topics that we really want to talk about quickly are going to be, next slide. The topics that we really want to talk about today, oh, that's weird. All right, well, ignore those arrows. But the topics that we want to focus on are the sensor capabilities, the physical workload, the cognitive workload, and the feedback that's inherent and needs to be displayed and conveyed to users and addressed in the design and development of in-vehicle gestures. So go ahead and go to the next slide for me, Tim. All right, so first we're going to start with sensor capabilities. Sensors are obviously what are needed to develop and use these things in the car. Some of the popular options out there you can see on the right. You've got the Leap Motion, which I think was one of the first ones. It's the first one that we used to really address the investigation of gestures and try and develop gestures. And it's improved a lot over the years. You also have the Connect there. The Connect can be used for more broad gestures. It can do full skeleton instead of just hand, things of that nature. And then below that is Project Soli, and this is actually a really interesting project by Google. And they have created is pretty much sonar for your hands. It works a little bit different than the IR gestures or sensors, but can do some really cool stuff. What we have to be aware of here, though, is that there's a lot of difficulties that depend on the sensor tech. You can have issues of occlusion, lighting conditions, which are very, very important in driving research as you go outside and can cause hazards with IR. And then you have things like sensor confusion. Sensor confusion being, can it detect the difference between a long swipe or a short swipe, or different levels of where my hands are? Can it always detect my fingers? Those things like that. So when you have these limited sensors, they require narrowly defined gestures to make sure that the system can read what those people are trying to say. But this can create some non-naturalistic movements. So can we go to the next slide? So some recommendations that we have for these sensors from our own research and from some of our publications is that you really need to focus on sensors matching with your design goals, making sure that if you want to do a full body gesture and your research design is focused on that, then you need to have a system like Kinect installed that will do that for you. A Leap can't do that. But if you're looking at a small finger gesture-based system, then maybe the Leap is for you. Or if you want to have it outdoors in the sunlight, then you need to determine, maybe I need to use something that's not IR-based. You also want to decide how you're going to be defining gestures. And if we're talking about the current level of gestures, what we found is you really need to define gestures with as few properties as possible. You really need to make sure that there's broad error ranges for individuals to make, because no one is going to ever do it as perfectly as the developer. And we found that in our own research where Keenan would develop a gesture and it would work just fine when he did it. And then I would try and do the same thing, but I would have some little finger out of the way or something and it wouldn't work. And so you have to make it very broad. And so things like hand pose, magnitude of movement, direction of movement, those things need to be kind of the main things you use in determining what a gesture means. These, again, the large tolerances are important. And then what we found in our research is the fewer gestures you use, the easier it is just for the sensor to determine what gesture you're using. Aside from cognitive and physical load, just asking the gesture to detect the fewest gestures is the sensor to detect the fewest gestures is ideal. Okay, next slide, please. All right, the next slides that we're going to talk about, we're going to kind of try to ignore the idea of sensors. Sensors really do limit and scope a lot of gesture research, but we're going to try and leave that in the back end and kind of, we can talk about it where necessary, but we're going to, from now on, kind of assume that we have perfect sensors. So in this world that you have these sensors that can always read what you want it to read, you still have to consider the physical workload of an individual using this. This is an issue for a number of things. If you have an individual who is trying to move through a list, and they're swiping multiple times, swipe down, swipe down, swipe down, swipe down, swipe down, instead of simply quickly turning a knob or pressing a button a few times, that takes a lot of physical workload. And so that needs to be considered. You also have large movements. If that's going to occur and you want to do full arm movements, well, that may manipulate the rest of your body, which in the driving situation is not necessarily ideal. And that can create this extra physical workload or confusion. So always consider these factors of how much workload physically is necessary to complete this gesture, and how does that match with the driving situation. If I need to do very fine detail changes with a gesture, that may create problems in a dual task situation while I'm driving down the road and the road is vibrating, things like that, guiding my vehicle. So for recommendations, we can go to the next slide. And it's really kind of basic recommendations on this. Don't use too fine of motor control because you're trying to do other motor control tasks at the same time, and you're going to be doing task switching. Be wary of the unnecessarily repetitive tasks, so that swipe, 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 swipe. Or if you're doing something like a level setting, where we found in level setting is actually very useful if you put an arm out and then raise or lower your hand. Well, if I'm going to do that, it's much easier if I can do that for a short period of time than having my hand out for a minute while I'm trying to drive with the other hand and get the setting perfectly correct. And then finally, you need to consider the other ergonomic issues that are inherent to the vehicle. So you're physically limited by space, you can only use one hand, all of these sort of factors that we should always be aware of. Okay, next slide, please.
All right, sorry, this is Keenan. I'm gonna take over now. Another consideration is cognitive or mental load. So air gestures are kind of odd because you don't have the physical affordances of something like a physical knob traditionally in a car, or even arguably a touchscreen at this point has an affordance of being able to tap on different things. As such, And until we have some kind of augmented reality displays everywhere, users basically have to recall which gesture to use and how to execute it. This creates cognitive load. It is definitely a hazard for gesture design, so you have to be really careful about which gestures we use and how many we use, because it may not be obvious to a person how they can remember these, especially in the driving context. A lot of discussion of gestures involves discussion of absolute mapped gestures. These are context-independent things. So an example of that is if you're driving your car and you could imagine mimicking the old crank-style windows. You could make that with your hand to roll the windows up and down. So that might be a nice thing if that were the only in-vehicle function, but there's been some calculations done on the number of gestures that you would need to do everything like that, and it's hundreds of gestures that you'd have to remember, and people have different cultural expectations and such, and so not everyone would have the same expectations. So even if they were highly naturalistic or intuitive, you would still have people forgetting which gesture goes to which and probably being frustrated. You don't want that kind of workload for a driver. Next slide, please. So as an alternative, we have a few recommendations on this point. The first is to increase the guessability of gestures. And one way you can do that is to try and match the likely mental model people are likely to have. And you can do this, you can get at this by incorporating participatory design, and specifically elicitation methods. So we've used a method called the theater approach, and you can see that over on the right, in which we basically show a participant a kind of a fake interface doing something. So in this example, the interface was selecting an item and asked the participant to suggest gestures that could have caused that. So the participant here, which is actually me, is pointing to the right. And so that gets us some interesting things. So you can basically get a sense for what different users might expect and what might be easier for them to remember, because it's essentially how they think it should work. These methods do definitely depend on your sample. So you want to get as wide a sample as possible, and they sometimes have limited generalizability in terms of generalizing to other cultural environments, other age groups, etc. But there has been some evidence that's shown that gesture sets designed via these methods are rated more highly than gesture sets that are designed purely by designers, just using their design thinking. So that's a good thing to kind of minimize the cognitive load. Things like stimulus response compatibility. So finding out even something as simple as how does a user mentally orient the space of a menu system? Do they find more of a direct manipulation metaphor more intuitive? So an example of that is on like iOS, the way you're physically moving content, or are they thinking of a metaphor of I'm swiping down to move a cursor or position down or adjust the setting lower? Things like that. All these traditional human factors things become kind of really important when you have a gesture system in which it's not immediately obvious necessarily how these things, how it works. Another recommendation is to consider relative mapped gestures instead of absolute mapped gestures. So these are context dependent, and it's very similar to the idea of on a mouse you have left click, right click, and scroll, and those work differently depending on where you are on your computer. Versus having something like versus having like a command that you would enter via text interface is kind of the equivalent of an absolute mapped gesture. So these would be a kind of limited set of maybe 5 to 10 different gestures, for maybe one for adjusting a setting, one for incrementing a setting, one for selecting, one for going back. So something like this, there's not nearly the amount of kind of memory load trying to recall. It's probably much easier to learn these number of gestures. The issue with this is that you need something like a menu structure, or voice input, or maybe pointing at different things in the car you want to manipulate. You need some way of determining context. So I would say similar to the way you can right-click on different things on your computer, you need some equivalent to that into the vehicle. And that hasn't not been researched that much. It would be an interesting source of future research. Next slide, please. So one additional difficulty is the lack of feedback. So again, with gestures, there's not traditional feedback inherent to their operation that you might get for something like a knob. So a knob, you turn a knob to adjust your volume, and you have this inherent click. The knob clicks for every notch, perhaps, that you turn. You have some sense of how far it's actually moved. So for some air gestures, you can imagine there may not be any direct feedback for what gesture has been recognized. This is especially potentially damaging when if a person's trying to guess, oh, is this a swipe or did I point to do this? And again, this may become less of a problem once there's more conventions that are established, but now it's unclear what those exactly would be. So this is kind of a difficulty. There's also a danger of, I've found with users spending a lot of time looking at a visual display to see if their gesture was recognized correctly. So, and again, going back to kind of the sense of limitations, if you're pointing to the right and you want to know if it actually recognized that as a point to the right or a point to the front or something, drivers can kind of increase their time looking away from the road, confirming whether these things actually worked or not. And again, that's because you don't have the click or et cetera, that you get from kind of a physical control, or even a touchscreen. And again, we go back to this heuristic of visibility of system status with one of Nielsen's 10 heuristics. They're always good to kind of go back to in all of these cases. So things the user might want to know, a lot of participants in some of my studies have wanted to know whether their hand was basically safe. So if there's like a zone where gestures are sensed, maybe over the center console or near the steering wheel, they may want to know if they can go ahead and gesticulate to their passenger versus when their hand is being tracked. And some sort of kind of ambient feedback might be good to indicate that. And again, also what input was interpreted as. Can we go to the next slide, please? So basically, we need to think a little bit more differently about displays, specifically how we use audio in order to provide the user feedback for things like this in the vehicle. So we found that auditory displays are actually quite nice for this. You can give audio feedback that allows the driver to know what their gesture did without needing to visually confirm or without just having general doubt about what it did. Haptics could also be explored for something like this. But importantly, I'm talking about auditory feedback that's probably in excess of what is normally seen. So usually, audio feedback in the vehicle is something like there may be a selection sound, etc., but it doesn't actually tell you enough to basically be operable through audio. So even something like text-to-speech, you could have your in-vehicle Siri could tell you basically what your gesture just accomplished. So we've done some research with things like that and found it to be pretty effective for adding feedback, addressing this feedback problem. Next slide, please. So to conclude this kind of brief overview of some major points, gestures can be hard to remember, and also they can be physically difficult to execute. To get around that, we kind of advocate having a small set of gestures that's easy to recall and also easy to master, and that also allows you to have kind of a wide tolerance in the amount of different movements that you can accept for a given gesture to accommodate individual differences. However, there's this research question of, in this case, how to determine the context for a system like that when a gesture could do different things depending on what kind of computing context you're in. And so we need more research on things like pointing in the vehicle, and that could require kind of more kind of whole cab, kind of holistic simulators that allow you to make the vehicle more of a kind of computing environment. Another alternative is kind of speech input or kind of traditional menu-based systems. We also advocate that kind of richer auditory feedback be used to allow the driver to figure out what exactly they've accomplished after they've done an air gesture, because there's a lack of other feedback. And in closing, we like to think about this as a really interesting kind of proxy for this future in which people are doing computing tasks while they're out in the world, while they're walking around, while they're riding their bikes. So research in the vehicle and the space we think is going to be really applicable in the future as computing becomes more ubiquitous. And that is it. The next slide is just a thank you slide. So does anyone have any questions about this content?
I have lots. I don't know if you can hear me.
Why don't you walk closer so that I don't have to repeat it? So.
If it's okay. I was just really curious because this is something we work at nowadays. So just wondering what use cases do you see it would be possible? I mean, I have my own ideas that when you're driving more autonomous, you have a different seating position, so you might not be able to touch the normal display, so you need some more flexibility there. But just a general question.
Yeah. Well, for the one we really push, we really think that the future of gestures are going to go one of two ways. Either you're going to have, or it could be mixed, but usually we're going to have some sort of controlling mechanism of going up and down a list or left and right in a list, a selection and a back button, and then a shortcut. So you're going to have shortcuts that yourself you might know and will be standard. But what we won't have is 400 gestures for different actions. That just is too many. That's how many options are in a standard car, and you're never gonna memorize that many. But the context dependent is becoming more interesting to us, and I think it's becoming more possible with today's sensors, where I could somehow point to an AC unit or say AC or things of that nature, so it knows exactly what I'm talking about. And I think that's the key to remember here, is that a gesture system I don't think will ever be on its own in a vehicle, but it will always be fused to other modalities of input, whether that be a touchscreen or voice or some other type of interaction as well. And I think that is potential use cases, is that meshing of what works well in gestures, what works well in touch, what works well in speech, together to create a very intuitive interface.
And also on that point of maybe the person is in multiple positions or locations in the car, we've thought about things that are essentially kind of like a trigger word that exists now in kind of ambient voice interfaces. So for example, there could be a certain hand pose that indicates that you're kind of ready to perform a gesture and enter that mode. And this could be a thing that once sensors improve, that you could be able to do essentially anywhere in any computing context. You could make this sort of enter this sort of physical, basically trigger word equivalent, and then you could be able to use your relative mapped gestures in any context. So,
and that trigger is very important in a situation where it's not always reading, or you don't always want to read it, because if it's able to read me at any point in the vehicle, and I accidentally make a gesture that is meant to do something, and I really don't mean that, because we make a lot of gestures when we articulate speech and things like that, we don't want that to occur. So having a very, it's like an OK Google or an Hey Alexa or any of those sorts of things. It's simply a trigger so it knows to listen and do whatever you say next.
I just had a comment of something you might want to append to your context considerations, which is the cultural context of gestures with all the users of the road, in terms of if there's interference between someone doing a gesture in the car and the pedestrian interpreting that gesture.
Right. That's a great point, and that's another thing that participatory design can help you get at. You can even ask the users in those studies to consider gestures they would not want. Consider whether they want their gesture to be seen by other drivers or other pedestrians. So yeah, it's a very interesting question, for sure.
This one is really bad to do. This one.
I think we've got time for one more question if someone's got one before we move on to the rest of the agenda. Any last questions for our friends from Georgia Tech? Thanks, Keenan and Tom. We're glad you could join us today, and I will provide contact information, so if there's any follow-up questions that people have, they can reach out to you guys directly.
Great. Have a nice meeting.
Thank you.
Bye.